the different products that we offer to our marine customers, but today specifically because it is for Alfa, for the ballast water treatment system, we will simply talk about that. And in the ballast water treatment research and development, Alfa Laval has been involved in one way or the other since late 1990s, and I have a slide later on which actually shows you the different stages of what Alfa Laval has done over the last 25-30 years. We just do a very quick update. We have approval from all major class societies, plus we have the type approval from the US Coast Guards as well. Overall, we have sold 6,000 systems globally with 3,000 systems retrofit installations. Without spending too much time, this is our major product portfolio group for the marine customers. If you don't know, just very briefly, Framo is now part of the Alfa Laval group, and so is the Aalborg boilers, part of Alfa Laval. And from our Australia office, we look after the customers within our region and can assist you in your global operations as well. Okay, the ballast water treatment, the legislation, as we all know, ballast operations are very vital on board the ships, depending on the loading, unloading, and different reasons for it. And the UN recognizes that the spread of the aquatic invasive species as one of the greatest threats to the world oceans. That's why the Convention for the Ballast Water came into force on 8th of September 2017. The ship owners and operators are required to have a compliant and approved ballast water treatment system for their ongoing operation. The 86 states have signed to the treaty, and 91, which is representing 91% of the world GT percentage. There are two different systems. Approving authorities, IMO, which covers the global market, and USA have their own legislation where the systems are the requirements are a bit more strict. But because we are operating, most of our fleet in Australia and nearby is operating under the IMO umbrella, we will be talking more about the IMO Ballast Water Convention today. Okay, just as I mentioned before, as per the IMO rules, it has now been ratified by 91% of the world GT gross tonnage, and ratified by 86 states globally. As per the rules now, the new vessels must be equipped with the ballast water systems at delivery, and the existing vessel should install one system between 2019 and 24. It is getting tied up, unless they have an exemption, and it is getting tied up with their docking dates as it happens. The revised G8, now G8, this is a testing mechanism which is used by IMO and US Coast Guards these are the testing mechanisms which are used to approve different systems, and Alfa Laval was one of the first systems to get the approval for the revised G8 regulations. Of course, there are, as we talk about through this presentation, there are other requirements that the customers and the ship operators need to comply with as well. And as you can see on the right side, I've included some information on the US Coast Guards regulations as well. But we will emphasize more on the IMO operations in this presentation. There are different technologies available out there. The one that we will be talking about in this presentation are only three of them: electrochlorination, chemical dosing, and UV treatment. Suppliers are concentrating on these three technologies, and Alfa Laval is using UV treatment for its pure ballast solution. So of course, the different factors that will affect the water characteristics that will affect the ballast water treatment operation. The three main to consider are the UV transmission, salinity, and the temperature. The main parameter of the UV system is the UV transmission. It is important to know the UVT values of the water that will be treated. UV transmitting levels in harbor usually ranges from 90 to 60%, but can sometimes fall to 50% or below. When UVT is low, more power is needed to the high UVT equals to clear water, low UVT equals poor water quality. And I will go through a bit more in details of how our system works and what is involved in there and things like that. Salinity is a chemical system. The companies which are supplying chemical system use high salinity water. Most ports are, as you know, could be exposed to the river runoffs, which means that the average salinity levels are generally lower. And in order for them to run their systems effectively in the brackish or fresh water, these systems will require the addition of salt or some type of high salinity water, which must be stored on board in order to be effective. Thankfully, for our solution, this is our systems are not dependent of the water salinity. Temperature, of course, is another factor to consider. Most of the EC, which is the electrochloridation process, the requirement is above 15 degrees centigrade with normal low end temperature in the range between 10 to 17 degrees. Water below 10 degrees significantly reduces the formation of chlorine, and the colder seawater therefore needs preheating in order for system to perform effectively and ensure compliance. Okay, just a very brief intro on the three systems that we talked about. Electrochloridation is the first one. The electrolysis of the seawater forms chlorine and hydrogen gas. The charge is introduced in the system, and the chlorine gas dissolved in the water produces sodium hypochlorite, which is used as a disinfectant. There are some limitations to this system, such as that in the fresh water, the power consumption is significantly increased. Also for these systems, the EC systems, these are normally referred to. They will additionally require hydrogen traps, flame arresters, and other methods to safely handle the hydrogen which is formed in the process. This allows for a one-way treatment, but that is when you're taking during the ballasting operation, the seawater goes through the whole operation, whereas when you're deballasting, it doesn't go through the treatment system. However, some kind of neutralization is required, which is again an additional system that you have to keep on board. In case of the UV system, Alfa Laval UV system, the water gets treated both during ballasting and deballasting operation. Also, again, with the EC systems, the electrodes cleaning is required, and which is again an extra labor or some step for this system to work. The holding time is another critical thing to consider when selecting a ballast water treatment system. Different systems have different limitations. As far as Alfa Laval system is concerned, we have 0-day hold time. We have only got 2.5 hours holding time before the water can be discharged, and that is only in the US for the US system and the systems operating in US. In Australia, we don't have any hold times requirements. The efficiency varies according to the condition of water, such as pH, salinity, and temperature, may affect the corrosion rate negatively for plain and stainless steel. The shortens the expected lifetime of polymers, the chemicals that you're using, and as I stated earlier, the neutralization chemicals are required, which are the added risk to crew and environment, because of course there is added chemical handling and all that required on board. Chemical dosing is again another treatment system technology used for the ballast water systems. The chemicals are made in a tank which is mixed with the ballast flow. Most common chemical used is chlorine dosing. Approximately 1 to 10 ppm of chlorine is dosed in with ballast flow. The chlorine levels is neutralized prior to discharge. That is, neutralization chemicals and monitoring is required, which is again another step and adds complexity to the system. Corrosion, of course, depending on the chemicals you're using, and of course, if you're trading internationally, the quality of the chemicals received at different ports can be different. So the risk of corrosion is very real in this case. The chemical handling and the environment impact to the must be considered as well. Again, the holding time is 24 hours or more and is required for the chemicals to work. Okay, then it's the next one we are going to talk about is the UV treatment. Of course, we are not the only one providing this solution, but of course, I will give reasons later on to say why we are the best in the business. The good thing about the UV treatment systems is there is no hazardous chemicals required. They're easy to operate, install. One slide back, the negative point can be there's a slightly higher power consumption than EC systems. However, our maintenance costs are low and they are safe and effective treatment method. Okay, the Alfa Laval pure ballast systems are equipped with the medium pressure UV lamps. They are medium and low pressure UV lamps, but we in our solution we use medium pressure UV lamps with a very high output, typically 50 times higher output than the low pressure lamps. And making them very effective. As I stated earlier, we have the type approval from all the major class societies and also the US Coast Guards, and we are revised G8 compliant systems. This slide, what we are showing, as I stated earlier, that we started the whole pure ballast research and development back in the late 1990s, and as you can see, the curve where we are as we have developed our different systems. And interesting thing for us to understand in the Australian market is that I came across our first and was involved in the commissioning and the operation and maintenance of the first ballast water treatment system in 2011-12, when the LHDs were commissioned, which are the HMS Canberra and HMS Adelaide. They have the first generation ballast water, Alfa Laval ballast water treatment systems installed, and hopefully that these will be upgraded to the latest version, hopefully within the next 12 to 14 months. So that was very interesting, and from there you can see with our continuous research and development, we have achieved different milestones, including the zero day hold time, revised G8 compliant, and getting approvals for operating in different environment and conditions and waters as well. Just a very okay, this is the Alfa Laval family, different reactors of different sizes. As you can see, what we are showing here are the reactors, and how many lamps are for different sizes, and some power requirements. Again, through our research and R&D over the time, we have improved our design by introducing the corrosion resistance SMO 254 for our reactors, which is the high alloy authentic stainless steel. This is specifically developed for the seawater applications, and it has a higher corrosion resistance than the 316 stainless steel. The Alfa Laval pure ballast systems are available in standard, compact flex, explosion proof, and Dex house configuration. And there are more slides to come, where I will briefly talk about what different systems look like. Okay, the next one, yeah. So these are the four. This is the family. This is the family for different needs and requirements. Compact, Flex, Standard, and EX version, and the capacities are given at the bottom. We also have a deck house. Another recent addition to the family is a deck is a deck containerized solution for the customer specific needs because of the space in the engine room one and few other factors, but that's not shown here. Just going through the component, as you can see, this is our standard system. This is a very simple inline construction where the water enters the filter before it is treated in the UV reactor, and it goes to the tank nominated tank. During the deballasting, the same operation is reversed. The only thing is that the water is only treated by the reactor and doesn't go through the filter. After every ballasting operation, this is all out. Most of the operation is automated. After every operation, our cleaning in place unit kicks in to clean the lamps, the UV lamps, and increase and just to ensure that the extended life and extended operational availability. And the filter, of course, is equipped with the backflush. Once it gets to to a point with after the certain operation, or depending on the DP, it will automatically backflush the system just to get rid of all the accumulated debris in the filter. So all the system is automated and with a minimum and a simple operation with a minimum human interruption. Through our initial system that were sold in different markets, one of the biggest challenges that we came across was how to put, as you can see, the normal system. Because customers have different requirements, especially if you're retrofitting in a small engine room. Space is a huge challenge for us to have to install our system. And one of the really big improvement that Alfa Laval came up was two systems, which is compact and compact flex. The one on your screen showing on a skid is an Alfa Laval compact system, where the whole system is on a skid. It is basically a plug and play system, and it is very easy to install and connect to the existing. Of course, there will be some piping required to be done after the system to the existing ballast water system on board. But as you can see, the actual installation of the ballast water treatment system is rather very simple and easy. And this system is available from 85 to 1,000 cubic meter capacity. And I must say, this is a very, a good product for us to sell. It's very, very easy to convince the customer, and they can see the benefit of this because the installation costs for these systems are a lot cheaper than the other systems, and which is I'm going to show you on the next slide. As you can see, the same system is supplied in different components. We call it a compact flex solution. Now, this system originally came from our purifier modules, where, of course, when space is an issue, then we supply the components, the system in component form, and the customer can then install at different locations within the allowable proximity and get the units connected and use it. So however, in the compact flex solution, as you can see, because of the installation requirements, the installation costs are higher than the compact. So of course, for us, the better option, the preferred option, and for the customer as well, to give them savings, we try to sell the compact systems. But that's not a viable solution, the compact flex is another alternative and a very effective one. This is where we simply, of course, the ballast water treatment system, depending on the ship size and the requirements and operational requirements, power is one big thing to consider. Remember, and what we are trying to say here in this slide is that as per our R&D and what we have seen in most normal operations, our power requirement is only 50% of the rated capacity for our system. As of course the system is automated, as the water quality deteriorates for whatever reason, the system will adjust the UV transmittance automatically. That means the required power consumption can go up as well. But as see, for most of the system under the normal conditions, operational conditions, the required power is only 50% of the rated capacity. Okay, now just a very quick few slides on the process, the actual process of the retrofit. This, of course, in Australia, most of our customers are coming to us for the existing ships. It's a small market, so most of our projects have so far been the retrofit projects. So in Alfa Laval, we have a global pool of engineering partners. These are the companies, willing and companies who we train on how these systems are to be installed and what to look for and things like that. And then they become our engineering partners and who we can refer to our customers for the 3D scanning, for the installation assessment and engineering reviews, etc. In addition to that, we provide ongoing assistance through our excellence centers in China and Europe, where our colleagues are on daily basis involved only in answering different questions from our customers regarding installation, regarding design requirements, etc., or any other question they may have from time to time for their selected system. We also, from Australia, when we sell the system, we provide installation checks. Once the pre-installation checks, actually, we visit I've done a few myself, where we go and visit the ship just to check for the available space. Then we talk to the customer for their requirements. And once the system is installed, after they have consulted, with the engineering company who's done the review and done the 3D drawing, just to and know where the system is going to will be installed, etc. Then we do an installation check before commissioning as well. Of course, as part of our supply, we provide local commissioning and we provide local training to our customers within Australia as well. And ongoing support. One of the biggest things to be proud of while working at Alfa Laval is the support that we offer to our customers after sales. Selling is one thing, once you're sold anything, obviously the fun parts comes afterwards, where you have to constantly answer the questions from customer. It's a new, it's a retrofit process and project. The customers keep on coming back to us with more and more questions, and the attendance for commissioning, for troubleshooting and all that, which we are very proud of to supply, not from overseas, not through an engineering agent. We have in-house within Alfa Laval capacity and capability through providing constant and training to our service engineers, Alfa Laval service engineers. Of course, depending on the level of interaction and all that, we keep some. We do keep some emergency space for different customers in Australia as well. One of the requirements for the ballast water treatment system is to have an annual compliance service carried out on, for the ballast water treatment systems, and this has to be done on each system on annual basis, and a certificate is issued at the end of the compliance service. And at this point in time, we are offering this service from 4 different global ports, and we will start this service from Australia with our local resources from actually this month. We have provided the training, we are ready to go, and we will be attending our first compliance service within March. Also, an added advantage, an added service that is offered free of charge to customers. It is the International Marine Service Help Desk. This is a service where the customer, while at sea, can get directly in touch with the Alfa Laval experts on different on different products, and we try to help them out remotely. It is a free of charge service, as I said, and if we cannot assist them, this one, we know the nearest sales company gets notified, and we try to help the customers when they at the nearest possible port with their issues and problems. Just the retrofit experience, we have worldwide so far, we have sold 6,000 systems. More than 3,000 have been the retrofit projects. As you can imagine, the ship size and the customer needs and requirements are very different. And every make sale that we make itself is a new project that comes with its own challenges. In Australia, over the last 18 months, we have sold 12 systems to different customers, including Royal Australian Navy to HMS Jules, the 3 systems, Incoship, where we supplied some EX version systems, TK, and just recently we have supplied 6 systems to a Queensland-based company, Sea-Swift. And that is one of the biggest differentiator for Alfa Laval was our local presence and understanding of the local market and customer needs. The other suppliers who are in our market either are operating through their Singapore or overseas offices, or they are operating through a local engineering company. Whereas in our case, when you're talking to us, when you're dealing with us, we are talking to Alfa Laval, you're getting services from Alfa Laval, not from a third party who may or may not be trained, and whereas we are developing and constantly working on our systems. Okay, over the systems that we have sold, as I have mentioned before, no 2 systems are same. What we have learned over the last 18 months or so is that it is very important that the customer is willing to invest the time right in the beginning of the project. That is to ensure that you have the available space, you have the discussion with the Alfa Laval approved engineering partner to do the required surveys of the system, the 3D scanning of the area, just to ensure that the right system is selected and everything that you need for the system to work is available. The later it is done, I mean, these are the things which we'll need to do at some point anyway. The later it is done, it will simply add to cost and delays of the project. So that is why this is one thing that we have the work is really important. And installation supervision is crucial for successful installation, and the commissioning and training. As I stated to you just now, it is always good that you're talking to the OEM rather than the sales company, sales agent of a supplier whom is not present in Australia. And especially in these COVID times, I mean, I think the need to have the local resources and the ability to respond to the customer needs was never important than what we have seen during this pandemic. Another initiative from Alfa Laval for our different products is which we are promoting now. Where we are monitoring the system remotely just to, and if it is playing up and trying to help out the customer. It is a service that is provided, that is being provided to different customers, and a cloud-based service where we monitor the system operating on different locations and globally, and we answer your service questions. We try to troubleshoot you, and you can approach Alfa Laval with your questions as well. Again, during this pandemic of COVID-19, the remote assistance, remote working with different customers have become a really important tool. And I'm sure you would have seen the same tools implemented by or being promoted by different companies as well. So this is something that we are offering with our systems too. Okay, the final slide, and hopefully I'm not too over the time. The careful evaluation and analysis of the most suitable system based on the vessel's operating routines, voyage duration, operation, water salinity, etc., are very important. Based on the operating routes, some systems required minimum hold time, and which can restrict the vessel's operation. Early planning and formation of project team involving all key partners, including the vessel's crew, is critical for retrofits. Consider ease of operation and maintenance as this impact on the crew workload, and be mindful that for ongoing compliance, the ballast water treatment supplies system has good after sales and service backup in the region that the vessel is operating in. And with that, I am open to any question that you may have, please.
Phil Helmore here, Asif, if you can hear me.
Yeah.
The question that I have is, whereabouts is the UV treatment applied? Is it applied in a tank, or is it applied to the incoming ballast water as it flows in?
It is applied through the incoming ballast water as it flows in. I will just very quickly, there. If you can see my screen, Phil, this is the system, yep. Our standard system, because it's a bigger picture. That's why I'm showing this one. As you can see from the bottom, this is where the water will be fed to the filter, and after the filter, as you can see the lamps, UV lamps. The water then flows through the reactor where the UV light is used to kill all the bacteria before it is discharged to different nominated tanks.
Right, okay. Okay, yeah, that's the question, thank you.
Yeah, and the same applies when we are deballasting. The only difference is the filter is bypassed in the deballast operation.
Does it go through the lamps again on the way out?
Yes. In our solution, the water gets treated going into the tanks and coming out, just to ensure that the compliance, just to reduce last risk, in the operation.
Okay, thanks.
Thank you.
Asif, Jeffrey here. I have a question concerning the materials used. You said that it's a high alloy austenitic steel, and it gives better corrosion resistance than 316L.
Yeah.
Do you know what the designation is? Is it 321 or?
For the reactor, we are using SMO 254, which is a very highly resistant, corrosion resistant material. That is again in some of our earlier models, this was not used, but over the time through our R&D, we are now using SMO 254, which is corrosion resistance for our solution.
Okay, thank you.
Steve, it's Steve Morant here.
Hi, Steve.
Can you hear me? Hi. You indicated annual compliance certification is required. Yeah. Now, is that an internal is that an IMO required classification, or is it through class societies, flag state, or is it just an internal Alfa Laval requirement?
No, it's an IMO requirement for the system to be in compliance, and the annual service compliance service has to be done by the OEM. And we will, for your case, we will be providing the service through Alfa Laval Australia.
And then do you do that in front of class or flag state, or do you just send us certification?
No, we will do this service and issue you the certificate, which is kept on board, and that's simply, you know, I mean, if you are asked by the class, you can show that certificate that the system is in compliance.
Okay. I also noticed you said that some of the other designs of ballast treatment systems were affected by temperature range. Is there a restriction against the Alfa Laval system in very cold waters or very warm waters like the Persian Gulf and such?
I think if my memory is serving me right, our temperature limitation is, I think, up to 45 or 50 degrees water temperature, which, you know, I mean, I don't think we will get to those temperatures anyway, Steve. And but if you like, I can double check that and get back to you. But I think that is the range that we are operating in, and same goes on the other side, on the cooler side as well. I'll double check and get back to you on that one.
Okay, thank you.
No problem.
I'll have one other question, since nobody else has jumped in.
Yeah.
You've indicated that the skids can be split down. And I mean, I know from our experience that the skids will be split down and installed in various areas. Is there a maximum distance between pump, filter, UV unit reactor, or can they be really remote from each other?
No, I think the limitations are given in the design guide, installation and design guide for various systems, and we ask our customers and the engineering partners to refer to the design guide that is supplied with each and every system. But this is mostly to do for the Steve, as I mentioned earlier, where space at one location is critical or not available, and that is why this solution works for that one, you know. But of course, at the time of when we are doing the system evaluation or the ship's evaluation, the distances will be considered as well.
I'm assuming that your remote monitoring offer now it can be retrofitted to any installed equipment that's already there. What sort of additional cost would you be looking at? And is there an annual cost to maintain remote monitoring? There
are some costs available for monitoring, very nominal. They are not too expensive. I'll have to check the systems. Actually, I think they are only a few €100 per month per system, if my memory is serving me right. But for your actual system, which you are going to be installed on Jules, I can get some more information and submit to you with some cost proposals.
Okay, thank you.
No problem.
Asif, Jeffrey here again. Can I ask you about the lifespan, or the expected life of a UV lamp?
I think it's the 10,000 hour, the operational running hours. If the running hour, okay, the running hours for the for the UV lamps.
Yes, yeah, for the UV lamps. I'm thinking that you wouldn't be replacing just one lamp. I wondered if there was a system in place for replacing them all at a set time span.
The running hours for UV lamps is 3,000 hours. And we have the CIP system to clean the UV lamps after each operation as well. At the 3,000 hours, of course, we will recommend replacement, or in other cases, you know, if it is broken for whatever reason, you know, then it may be required to replace that only one lamp. If only one is broken, then we will only replace one. We're not going to replace all of them.